Hey everybody, Mr. Judson here. So today we want to talk about inequalities. Okay, if we have some function, we want to know where is that function greater than or less than, or maybe greater than or equal to, or less than or equal to 0. And so if I've got some function, so this is just a random graph that I drew, and I want to know where is f of x less than or equal to 0, well that means where are the y values negative, because we're less than 0. Well that would be this part of the graph right here, and also this part of the graph right here. Now when we say where is f of x less than or equal to 0, what we really want to know is for what x values, right? Whatever this x value right here is, for everything less than that, this function goes down forever, it's going to be negative. So all these values out here. So this is going to be an important point to being able to answer that question. Also right here, I cross the x-axis in these two places, and for this part of the graph, my y values are less than or equal to 0. So what I'm going to have is an interval here of x values. All right? So let's just say that this x value was a, and this one was b, and this one was c. My answer would be x is an element of, that's what that symbol means, it's an element of. I mean, it's got to be in this set of numbers that I'm going to write down. I'm on the interval from negative infinity to whatever a is. And because of the equal sign, I want to put a bracket there. Right? No brackets at negative infinity because you never get there. And then also, part of my answer is all the x values between whatever b and c are. So, or the interval b to c. Now, if I took this equal sign away, the only thing that would change here is all the brackets would become parentheses. Because I don't want to know where it equals 0, I want to know where it's less than 0, where we're actually below the x-axis. So even though this is talking about y values, where they're negative, or if that was greater than or equal to 0, then I want positive y values, my answer is really the x values where that happens. Okay? So now the question is, how do we find those x values? Let's start with a sample problem. All right, so I've got a parabola, quadratic equation, and I want to know where is it equal to, or I'm sorry, where is it greater than 0? Okay, I want to know where is this thing greater than 0. So in other words, where is it above the x-axis? We know what a parabola looks like, right? My coefficient here is positive, so I know the parabola opens up. So my guess is part of this parabola sits below the x-axis and part of it is above. It's these two parts out here that I'm looking for. And I don't even have to graph this to be able to answer the question. I'm going to show you guys a method that we could use to answer this without graphing at all. And so the first step is I want to find the zeros. Okay, that's something we've been working on, right? I need to factor this, so I'm going to call this x times x. I want two numbers I multiply to get 24 and subtract to get a negative 5. That sounds like 8 and 3. If I want to get a negative 5, I should do 3 minus 8. So positive 3 minus 8. And again, always multiply it out, double check, make sure you come back to this. X squared, negative 8x plus 3x, that equals this one. And positive times a negative, yep, negative 24. So that means that my zeros are at x equals negative 3 and positive 8. Now, I would say right now we should be able to answer this question. If we know the parabola goes like this, It's the areas this side of -3 and this side of 8 where we're above the x-axis, okay? But it's not always that easy. So I want to continue working with this and develop a strategy that we can use for any problem. All right, so once I find the zeros, then I want to draw a number line and plot the zeros. All right, so here's my number line, and I'm at -3. So if you want to go -2, -1, there's 0, and then 1, 2, 3, 4, 5, 6, 7, 8. There's 8, continues on this way. I don't put all those tick marks in there. What I usually do is, I usually do something like this. Here's my number line, there's -3, there's 8. I really don't care where 0 is. I don't care where all these tick marks fall. What I'm trying to do is I'm trying to break the number line down into intervals. All right? So we're trying to create intervals. And so I've got my intervals now. I've got -infinity all the way to -3. I've got from -3 to 8, and I've got from 8 to positive infinity. And so my next step here is I want to pick numbers and test each interval. Okay? So what that means is I'm picking numbers inside these intervals and using them as a test number. So I need something less than -3. Doesn't matter what you choose. Let's just choose -5. A number between -3 and 8. I want to make it as easy as possible. So 0 or 1, I'll pick 0. And some number out here, I'll pick 10. Okay? That's a number larger than 8. And I'm going to test each of these numbers. When I say test, what I'm doing is I'm trying to decide, do I get an answer that's greater than 0 or less than 0? And in the end, I want the ones where we're greater than 0. So I'm going to take this test number, I'm going to plug it back into the factored form of this equation. Now, one thing I didn't mention, but we've kind of said it before in class, it's really, really important to make this equal to 0, or greater than or less than 0. I want 0 on one side, because at that point we're just talking about above or below the x-axis. If I had a 4 over here, okay, now I got to go up 4 units, and now I'm talking about above or below the line y equals 4. I don't want to think harder. I want to make this as easy as possible. Okay? I want y values that are above the x-axis. Okay? So what I'm going to do is I'm going to take this test number and just plug it in and see what I get. If I put in a -5 right here, I get -2. If I put a -5 in here, I get -13. And a -2 times a -13, I don't really care what the answer is. I just want to know, is it positive or negative? Right? Because if it's positive, that means it's above the x-axis. If it's negative, it means we're below the x-axis. So usually what I do is when I plug this in, I just go, okay, that's negative, negative times a negative is positive. And that's what I want, numbers greater than 0. So this interval checks out. Now I'll plug in a 0 and try it. Put in a 0 here, I'm left with +3. Put a 0 there, I get -8. Positive times a negative, that's negative. I don't want that. I want values greater than 0. So I'll just put an X there. And then if I try 10, 10 plus 13, that's positive. 10 minus 8, that's positive. Positive times a positive is positive. That checks out. And so now I found the intervals where this function is greater than 0. Okay, so once I pick my test numbers and I test each interval, then my last step is to answer the question in interval notation. So I'm going to say x is an element of, it just means it belongs, the x value belongs in one of these intervals. From negative infinity all the way to negative 3. Bracket or parenthesis at negative 3. If we go back and look at the original problem, there is no equal part to this. So I don't want to know where this equals 0. I want it to be greater than 0. So that means no brackets. Right? Essentially, if the equal sign is here, with that greater than, if it's greater than or equal to or less than or equal to, brackets. If it's just greater than or less than, parentheses. Okay? So I want a parenthesis here, or I want the interval from 8 to infinity. There's my answer. Now, even though I know in my head, if I was to graph this, and I got a point out here at 8 and a point here at negative 3, and my graph looks, it's a parabola and it looks like this, even though I know all this stuff, and I probably could have answered this without doing any of this work, I guarantee you we're not going to get one this easy on our test or the Central Washington test. It's going to be a larger function than this, bigger exponents, more numbers. So we need to make sure we understand this process. Okay? Let's try another one that's a cubic. So remember our steps. First thing we got to do is we got to find the zeros for this function. You know, and if we look at that and we go, how am I supposed to find the zeros? Like, how do I factor that? Synthetic division. That's what we've been working on, right? So synthetic division is a tool that we needed to be able to do this problem. So you guys go ahead and try it. Find the zeros. Go ahead and make a number line, and then start testing each interval. All right, so I'm going to write down my coefficients. 2, 13, negative 8, negative 52. And I'm going to do synthetic division with numbers that divide into 52 evenly. So I'll just make a list over here. I've got plus or minus. I don't know what's going to work here. I know 1 goes into there. I know 2 goes into there. 3 divides into there. No, that'd be 51. That doesn't work. 4 divides into there. And there's some others. But for right now, I'm just going to start working with those. I don't really have to make the full list. I just need to find something that works. Okay? I'm not going to try 1 because these don't add up to 0. 1 only works if those all add up to 0. So I'll try 2. Bring the first number down, I'll multiply and get 4. Add it to this, I get 17. I'll multiply here and get 34. Minus 8, that would be 26. Oh, look at that, I got lucky. 2 times 26 is 52. Add it to this, you get 0. Luck. All right, so at this point, I know that what I have is x minus 2 for a factor. This is going to be 2x squared plus 17x plus 26. And so now I want to try and factor this. I just give you a hint. All of these factor, all right? I'm not going to give you guys something that won't factor. I mean, you could. It could be we have to do a quadratic formula and get decimal values and check those intervals. But this is something new to us, you know, so I'm not going to give you something messy and ugly. Actually, we probably won't even get to that this year. These numbers will stay pretty clean. All right, so let's see. This has to be 2x times x. And 26, if I go 13 times 2, I think that works. So 13x plus 4x, that does equal 17x in the middle. All right, and I want to know, where is this less than or equal to 0? So I know where my zeros are. I've got zeros at x equals 2, a negative 13 halves, and a negative 2. So now I need to plot those on the number line so I get my intervals set up. So let's see, this is really a negative 6.5. So we can write it that way if we want, or you can leave it as 13 halves. Then I would hit negative 2, and positive 2, that would be the largest number. So now I need to pick a test number inside each of these intervals. Well, if that's a negative 6.5, let's just go negative 10. Okay? And something between a negative 6.5 and a negative 2, I'm going to make it as easy as possible, negative 3. Here I'll choose 0, and here I'll choose a positive 3. So I have 4 intervals here that I have to test to see what's happening with this function. So I always want to be able to go back and see my factors, because when you have this, a 0 over here, all I need to do is look at this and think to myself, positive times a negative, or negative times a negative times a negative. I just want to know, is the answer less than 0? I'm looking for negative answers, right? So if I plug in a negative 10, I get negative 12. Put a negative 10 there, I would get negative 20 plus 13, that's a negative number. So I got a negative times a negative. Put a negative 10 there, that'll be a negative 8. So I got a negative times a negative times a negative. 3 negatives, that means this is negative overall. And that's what we want. So there's part of my answer. If I put a negative 3 in, I get a negative 5. That'll be a negative 6 plus 13, that's positive. Put a negative 3 here, that's a negative 1. A lot of times what I'll do just to keep track of the signs is I'll go negative, positive, negative. That's what I got for each of these 3 factors. And so 2 negatives, that makes a positive, times another positive, positive overall. Not what I want. Here if I plug in a 0, I get a negative number, a positive 13, and a positive 2. Negative, positive, positive. Overall, that would be a negative answer, right? So that is what I want. So check that off, that's one of my intervals. And if I test the number 3, I get a positive 1, positive number there, positive number there. Overall it's positive, and I don't want that one. All right, so one thing that I notice on this is it seems to change from negative, positive, positive. Like we alternate back and forth between the signs. That happens a lot, but it doesn't happen all the time, okay? We need to make sure we're aware of that. I don't want people to go, okay, once I know the first one, I know all the rest. You know, we don't. We have to check them. Especially when you get multiplicity issues, you know, even multiplicities in there, it can change things. Or if you have a fractional expression, it can change things, okay? So, so we just want to be aware of that. So what I'm seeing is that these are my 2 intervals for my answer. So my final answer is this, x is an element of this interval from negative infinity up to a negative 13 halves. And since I have an equal sign this time, I want to make sure and include a bracket. Or x is going to be in this interval from negative 2 to negative 2. There's my answer. All right, let's try another. All right, so on this problem, I mean, right away we notice there's something different. We don't have a 0 over here, okay? But we can make that happen. That 0 is really important to these problems. Because again, I want to be able to say, where is it above the x-axis or below the x-axis? So I would start this problem by moving these over to the other side. So I would have x to the 4th plus x cubed Here's my x squared term. I move it over, it becomes negative. This x will become negative, and then plus 6. And I want that to be greater than 0. So again, we've got a little bit of work here with synthetic division. We've got to find our 4 zeros, and then break it up into intervals, and then test each one. Okay? You guys go ahead and try this one. All right, so yeah, these are going to take a little longer. We just got to be, okay with that. So my coefficients, 1, 1, -7, -1, 6. And I'm going to do synthetic division with numbers that divide into 6 evenly. So plus or minus 1, 2, 3, I was about to write 4. 6. So when I look at these, my first thought is they all add up to 0. That means 1 works. I like it. That just helped me out a little bit. So bring the first number straight down, multiply, you get 1, add it to this, you get 2. 2 minus 7, that's a -5. A -5 minus 1, that's a -6. -6 plus 6, that's 0. Now I'm going to do synthetic division with this next set of numbers. I'm not using the 0. Okay, I still have all the same options. This does not add up to 0, so I know 1 won't work a second time. So I should try something else. I'll try 2. Bring this down. Let's see, I'm going to multiply. I get 2. After this I get 4. And then I get 8 minus 5, that's 3. And then 6 minus 6. I don't know what it is, you guys. I don't ever remember getting it right on the first couple tries as often as I have this here. I usually go 1, 2, I'll try half the numbers, and if they don't work, then I'll go to the negative numbers. That's kind of my standard way of doing it. And apparently we've just had some equations that work with that. Okay? Alright, so I've got x minus 1 as a factor, x minus 2. This is going to be x squared plus 4x plus 3. So I still have to factor that. And so I'm going to get x minus 1 times x minus 2. This will be x times x. And 3 times 1, those add up to 4. And so that means that my zeros are at x equals 1, 2, -3, and -1. It would have been nice if maybe some of these repeated themselves, because then that would be fewer intervals, but that didn't happen on this one. Alright, so I've got -1, and then +1, and then 2, and then 3. And so what I need now is a test number in each of these intervals. So here I'll do -2, here I'll do 0, here I'll do 1.5, 2.5, and 4. And sometimes we look at that and we go, oh, decimal numbers, really? Well, remember, I don't have to figure out what this equals. I just have to decide if I get a positive or negative result. That's all that matters. And when I plug these test numbers in, I'm always going back to the factored form to plug it in. That's really important. Okay? Could I go back to the original equation and plug it in here? Sure, I could, but that's not very easy. When you plug it into the factored form, then all you have to do is decide if you've got positive or negative numbers, and once you multiply those, we'll know if we're going to get something greater than 0 or not. So greater than 0. I want to see something positive here. All right, so if I take a -2 and I plug it in, I'm going to get a negative number here, negative here, positive, negative. Overall, if I multiply that, there's an odd number of negative signs. That means overall my answer is going to be negative. Is that what I want? No. Plug in a 0. You get a negative times a negative times a positive times a positive. Even number of negative signs. That means overall that's positive. That's what we're looking for. Plug a 1.5 in. This will be positive, negative, positive, positive. So overall that's negative. I don't want that interval. If I put a 2.5 in, positive, 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 positive. So I want that interval. And if I put a 4 in, I get positive, 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 positive. So that's positive overall. So that works and that works. I'm looking at this and I'm thinking to myself, the only way I get two intervals that work, if that's a 0, is if it bounces. And the only way it bounces is if I've got a multiplicity of 2, and that didn't happen. So I'm a little confused about my answer here. I didn't expect to see that where I had two intervals side by side that worked. If that in fact is a 0. Oh. You guys see my mistake? See, this happens to me all the time. I make mistakes just like anybody else. And if we were in class, I know somebody would have called me out on this. That factor x plus 3 means my 0 is at negative 3. Yeah. So let's see, that should have been negative, which means if I extend this out and I get negative 3 right here, that never should have happened. So I can go back and erase that. And now I need to check this interval. So if I would have tried a negative 4, I would get negative number here, negative number, negative number, negative number. And overall that's 4 negative signs, which means that's positive, and that works. You know, when I didn't get all negatives here, I thought something was wrong. I probably should have stopped and thought about this, but I didn't. All right, now I see what the intervals are. So x is an element of either the interval that goes from negative infinity to negative 3, or the interval that goes from negative 1 to 1, or the interval that goes from 2 to infinity. There's my answer. All right, so we got one more example to look at, and this is the question, what happens if we have a fraction here? Sounds like it would be a lot more difficult, but it really isn't. Let's try it. All right, so I know when you look at this, you go, oh no, come on Judson, not fractions. I don't think this is any harder than the last ones we've done. Okay? Actually, it might even be easier. What I want to do is I want to start off doing the same thing. I want to factor the numerator and denominator. So when I look at this, I could factor an x out of here. So now I get x minus 3. And here I have x plus 1. I still want a 0. That 0 is really important. Okay? And now, instead of saying, where are the zeros, I'm going to change the question just a little bit. Where is the function equal to 0 or undefined? Okay, see, in the past we just said, where is this function equal to 0? Where are my zeros? Now I'm going to say, where does it equal 0? Now remember, the only way a fraction equals 0 is if the numerator equals 0, right? Or where is it undefined? That kind of falls into our domain issue. Denominators cannot equal 0. Okay, so we would say that the zeros are at x equals 0 or 3, and it's undefined at x equals -1. There's a term for this. We call these critical numbers. And the reason for that is they are critical to what's happening in relation to the x-axis. These are the points where we're going to change from maybe a positive y value to a negative y value. Okay? So those are critical to being able to answer this question. So now what I do is I break this down into intervals, same way we did before, and even though x cannot equal -1, okay, we're undefined there. Real important we get that. That means x cannot equal -1. No brackets at this number. Okay, but we have an equal sign, so I could have brackets on these two numbers. I'm going to break the number line down into intervals. I'm going to test those intervals. It's just that instead of multiplying, now I'm going to multiply, multiply, and divide. Okay, so you guys see if you can finish this up. All right, so if I take -2 and I test that, and I plug it in right here, I've got a -2 times a -5 divided by a -1. Negative, negative, divided by a negative. That's 3 negative signs total. That means I'm going to be negative overall, and that's what we're looking for. So that works. If I try a -1/2, that'll be negative, that'll be negative, but that'll be a positive 1/2. So negative, negative, positive. All I care about is the number of negative signs. If it's odd, the overall answer is negative. If it's an even number of negative signs, the overall answer is positive. Okay? So that's going to be a positive answer overall. Not what we're looking for. If I try 1, I get positive, negative, positive. That's 1 negative sign. So you don't have to write all this stuff down. It's just if it's helpful to you. And that's what I want, so that works. And if I put a 4 in here, I get positive, positive, positive. So that's positive overall. I don't want that. There's my answer. This interval of numbers and this interval. And just to make sure we understand what we're saying is when we say x is an element of the interval from -infinity to -1, and remember, x can't equal -1. Or, we're in this interval from 0 to 3. It's okay to equal those. That's where my zeros are. So I want 0 to 3, that interval. What I'm saying here is if you pick any negative number to the left of -1, so smaller than -1, and you plug it in here, you're going to get a true statement. You get an answer that is less than or equal to 0. If I pick any number between 0 and 3, I'm going to get an answer less than or equal to 0. If I pick 2.9, I'm going to get a true statement here. I'll plug it in, I'll work it out, I'm going to get some negative number as an answer. That's what we're saying. Okay? There's a lot of numbers you can plug into this equation and make it true. And we're saying that you can pick any x value in this range of numbers or this range. All right, that's what we have for today, solving inequalities. Let me get you guys a homework assignment. All right, so I just noticed this as I was checking the assignment to make sure everything right. When I was planning things, I actually got 2 sections switched around, which is okay. 2.6, we graph rational functions. Not like the ones we did in Chapter 1, but some more complicated ones. This is probably a better transition to do this first and then get into that. So we're going to skip to section 7 and do this assignment, and then we'll backtrack to section 6. Okay? So assignment number 13, this is our Monday, Tuesday work. We're on page 204, we're going to do 19 to 21, 23, 29, 47, and 48. All right, there it is, you guys. That's what we have for today. Take care of yourselves. Stay safe. We'll see you later. Bye.